My name is Edgar Carell. I'm here with my classmates Alana Ortiz, Jorge Carrasco, Joel Alvarez, Emmanuel Urena, and Nicolas Garcia. And today we're going to be presenting our Dynamics Final Rocket project. To start off our project, we're going to go ahead and start with the abstract. So the abstract starts off with the project begins with the understanding and application of the important roles that rockets play in science and in modern society. Although rockets work by expelling gas, smoke, and flames from the nozzle end of a rocket engine, which results in a reaction force propelling the rocket in the opposite direction. Each model and price depends on the purpose of the application. When a rocket lifts off, combustion product from the burning propellants accelerate rapidly out of the engine. Now, the next part is how a rocket functions. In the case of rockets, the action is the force produced by expulsion of gas, smoke, and flames from the nozzle end of a rocket engine. This can also be referred as Newton's third law, where there is one reaction, there is an opposite reaction. The reaction force propels the rocket in the opposite direction. So, when a rocket lifts off, the combustion products from the burning propellants accelerate rapidly out of the engine.
The importance of using rockets. It is well known that the Soviet Union and the United States were in a race to explore space and invent newer and more advanced technology. Since then, because of funding and brilliant minds, our knowledge of space has become so vast that we know more about Mars and the moon's surface than we do about our own ocean floors. With rockets, we can supply for ourselves satellites, which we use to communicate with each other over huge distance and to navigate our surroundings just by using Google Maps. Not only that, but rockets continue to send supplies and people to international space stations, and without the regular use of rockets, would not stay functioning. Another use for rockets is to explore the universe around us and understand it better. Thank you.
Next, I'm going to talk about the examples about their use in our society and important applications. So there are many examples of rockets. Some of the most well known include the first one example is space rockets. These are used to launch spacecraft and satellites into orbit, explore other planets, and conduct scientific research in space. Some of the examples include the SpaceX Falcon 9, NASA's Saturn B, and the Russian Soyuz. Next, we have military rockets. These are used for the defense purposes, such as missile defense systems or international ballistic missiles. Some of the examples include the USA Army's Patriot missile and Russia's Triple M missile. Then we have the fireworks rockets. These are used for entertainment, such as in fireworks displays. Some of the examples include the bottle rocket, sky rocket, and Roman candle. Another type of rocket, we have the model rocket. These are used for hobby and educational purposes, such as in science classes or at rocketry clubs. Examples include the Estes rockets and the Quiz Aerospace rockets. And finally, we have the jet assisted takeoff YATO rockets. These are used to assist aircraft with takeoff, ensure runaways, or on aircraft carriers. Examples include the Aerojet General Yato and the Rato, which means rocket assisted takeoff. These systems is used on military aircraft. Thank you.
All right, now I'm gonna talk about the different models and their cost. So the first model we have is the V2 German liquid propellant rocket engine. It was developed during the Second World War in Nazi Germany. It was made between the years of 1936 and 1942. It's the world's first large-scale liquid propellant rocket. It's also the first artificial object to go into space. It used a large-scale liquid fuel in rockets, and now it is how most rockets are made. It cost 100,000 RM, which was the currency Germany used in the year of 1944. Now the next model is the 5 Ariane. It's a series of European civilian expandable launch vehicles for space. It has a launch mass of 732. It's flew 16 times with 1 failure and 2 partial failures. It was launched in French Guiana. The top speed was 37,476 kilometers an hour, and the cost is $178 million. The next model is the Saturn V from the US. It was flown from 1967 to 1973, and it was used to explore the moon. It was 363 feet tall. It was able to take 24 men to the moon. The last time it was launched was in 1973. It's been launched successfully 13 times, and this was developed by NASA under the Apollo program. And this model cost $185 billion. The last ship is, or the last model is a Starship. It's the largest and most powerful rocket ever launched. The last flight was recently on March 14th of 2024. Its top speed is 16,000 miles per hour. The height of the rocket is 120 meters, and the cost of this rocket started at $5 billion, but it has now gone up to $10 billion. Thank you.
Rocket prototype. The modeling process was based on research and a deep understanding of aerodynamics and the elements that guide the rocket. The digital prototype was designed using Rhino 3D, which offers a wide range of features such as freeform modeling, parametric designs, and seamless import and export capabilities. This versatility allows flexibility in creating and modifying designs to meet specific needs. Rhino also has a wide variety of plugins, such as the Air Simulator or Caramba 3D, a structural and material behavior simulator. This can be very useful if the project goes beyond the design phase. To create the physical model, the same 3D digital model was used in a scale of 1 by 1. In order to make the printing process more efficient, the surfaces were converted into a mesh, which helped to simplify the file. The physical model was produced using a 3D printer and PLA filament, which is a type of polymer. The printing process took almost 18 hours to be complete. Thank you.
To find the height and displacement of the rocket, I took the time of how long the rocket was in the air after takeoff, and then I took the initial velocity and I converted it to meters per second. And then afterwards, we took the weight of the rocket and converted it to kilograms. And I used that to find the acceleration first, and then used that to find the final height, which was 9.37 meters. And then to find displacement, I just used the initial velocity plus the final velocity. And then I multiplied that times the time, and then times half of that to get the displacement of 53.644 meters. And to describe how our rocket works, we use the basics of chapter 12, which talks about kinematics of particles, which is a branch of classical mechanics that describes the motion of different particles in space without considering the forces that cause such motion. It focuses on velocity, acceleration, displacement, and time-related properties of a particle's motion.
So, in conclusion, and for our future research, in this project, we explored the crucial roles that rockets play in both historical and contemporary contexts, underscoring their importance in extending our reach beyond Earth through examining various types of rockets used for space exploration, military defense, and education. We've deepened our understanding of these machines by their design and their function. We also looked at how advancements in technology and economic consideration influence the development of rockets. By applying principles of engineering dynamics, especially kinematics, we've learned and grasped the complex physics behind rocket propulsion. As we move forward, it's clear that developing more efficient and sustainable rocket technologies will be key, particularly as our ambitions in space continue to grow. This project has shown that rockets will remain essential in our journey to new frontiers, both on Earth and in space. Also, another thing that we've learned here is that, working as a team was very beneficial for us. We learned how rockets work. We learned how working as a team works, how engineers design and develop things. So, in conclusion, this was a very fun project for all of us, and it was a learning lesson. So this is we left our references out on the bottom right. Thank you so much, and have a wonderful evening.